Graphs of the other trig functions. I'm going to graph tangent, cotangent, secant, and cosecant. So first of all, tangent. Remember, tangent is sine over cosine, or y over x. Think of the unit circle. If you're around the unit circle, at 0, tangent of 0. At 0, x is 1, y is 0. So tangent of 0 is y over x. 0 over 1, which is 0. So I'm right there at that point. Let's say I'm at pi over 4. At pi over 4. Remember, at pi over 4, my triangle, that's 45 degrees, my triangle is 1, 1, radical 2. So the tangent will be 1. So wherever pi over 4 is, I'm at 1. So there's pi over 4. 3.14 divided by 4. That's about 0.75, about. And you can do pi over 6 and pi over 3 if you want to. And you'll figure out that it's, somewhere in here. If I'm up here, tangent is y over x, so it's 1 over 0. So it's undefined at pi over 2. So pi over 2 is an asymptote. It's a vertical asymptote. It never touches that. So the tangent gets closer and closer to that dotted line, but never touches it. So now let me go the other way. If I go pi over 4 this way, so negative pi over 4. So again, a 1, 1, radical 2 triangle, so the tangent of negative pi over 4 is negative 1. So I'm right about there. And you could figure out if you wanted pi over 3, and you could figure out where that would be, or pi over 6. At right here, negative pi over 2. X is 0, y is negative 1. So tangent is negative 1 over 0, which is undefined. So it's undefined here at negative pi over 2. Okay? And then it continues on. If I kept going around the circle and doing graphs around the circle, I would be at different points around the circle. So right here, might be right about here. Back down here is undefined. So at 3 pi over 2, I'm also undefined. Or at negative 3 pi over 2. And you could keep going around the circle if you wanted. 3 pi, this is 1 pi over 2, 2 pi over 2, 3 pi over 2. If I keep going around the circle this way, 4 pi over 2, and 5 pi over 2. 5 pi over 2 again would be undefined. Okay? So the graph are the blue lines. The dotted lines are just there to show you that they're asymptotes. The blue lines never touch them. They get closer and closer, but never touch. So now that I have a few periods graphed, you could see that it goes from here to here, and then it repeats itself. Here to here, it repeats itself. So from here to here is pi. From here to here is pi. From here to here is pi. 2 pi over 2 is pi. So your period length is pi. At 0, pi, and 2 pi, at those zeros there, at 0, that right there is pi, 2 pi, and so forth, 2 pi. Those are my zeros for tangent. They're also the zeros for sine. It's undefined at pi over 2, and 3 pi over 2, and 5 pi over 2, and negative pi over 2. Those are the same as the zeros for cosine. Cosine's a denominator because it's y over x. Remember, sine is y over r, cosine is x over r. So tangents, sine over cosine, y over x. So zeros of sine correspond to zeros of tangent. Zeros of cosine correspond to the asymptotes in the tangent graph. Okay? Next graph. Oh, and you can put this in your calculator and see that you get the same thing. If you pick up your calculator, y is equal to, if I want to do tangent's right there, so tangent of x. And if I want to graph it, here's the graph. And that's the graph I have there. Okay? Cotangent. Cotangent is x over y, or cosine over sine. So again, now the zeros of cosine will be the zeros of this graph here. And the zeros of sine, zeros of cosine are the zeros of cotangent. The zeros of sine would be the asymptotes. So pi, and 2 pi, and so forth. Okay? And you can, again, if you want, think of the unit circle, and figure out, okay, that point I'm 1, 0, I'm at 0, 1, I'm at negative 1, 0, I'm at 0, negative 1. And remember, cotangent of whatever my angle is x over y. Okay? So at 0, x over y, it's cotangent, or cosine, cotangent, x 1 over 0 is undefined. So there's my undefined. If I do maybe pi over 4, at pi over 4 I'd be at 1. At pi over 2, I'd be at 0 over 1, which is 0. 1/4, 2/4, at 3 pi over 2, I would be at negative 1. That's right about there. At pi, x is negative 1, y is 0, I'm undefined. And then keep going around the circle and you get the graph. So here the period length is also pi, just like the tangent. My zeros are at pi over 2 and 3 pi over 2. They're the same as the zeros for cosine. It's undefined where sine is 0. Undefined where sine is 0, which would be 0 pi, 2 pi, negative 2 pi, and so forth. So there's the cotangent graph. And you can put it in your calculator, 1 over tangent, and you'll see that you get cotangent. The secant graph, I think the easiest way to graph any secant graph is to first graph the cosine graph. Whether it's cosine of x, cosine of 2x, cosine of 2x minus 1, whatever it is, graph your cosine graph first. And then once you graph the cosine graph, you know, since secant and cosine are reciprocals of each other, wherever cosine is 0, it'll be undefined. So there's cosine 0, so there's an asymptote. Here's cosine 0, so there's an asymptote. Here's cosine 0, so there's an asymptote. So these are all asymptotes. Wherever cosine is 0, those are all asymptotes. Okay? Once you graph the cosine curve, then all you have to do is wherever there's a max for the cosine, in blue, draw a U between your asymptotes. Wherever there's a minimum, draw an upside down U between your asymptotes. So here, just draw the U's. Okay? So that's the easiest way to graph them. Okay? And I can, if you want, a calculator if you want. y is equal to 1 divided by the cosine of x. Whoops, didn't get my divided by. 1 divided by cosine of x. And there's my secant. Okay? So the easiest way to do that, graph your cosine graph first, and then graph what the secant looks like. Remember the reciprocal function. Wherever cosine is 0, secant is undefined. When cosine is at its maximum value, secant will be at a minimum value. When cosine is at a minimum value, your secant will be at a maximum value. And then how long does it go before it starts repeating itself? Well, here, and then it starts repeating itself, because here's a u, here's an upside down u, and then it repeats u, upside down u. So from here to here is pi, or 2 pi, sorry, pi, and plus pi, 2 pi. Yeah, that's 1 period, 2 pi. Okay, so that's a regular cosine graph. And if you were going to graph cosecant, same idea, except since cosecant's a reciprocal of sine, you would graph the sine curve, which is the green one there, and then wherever there's a 0 for sine, it's an asymptote. So there's my asymptotes, 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 and an asymptote, and another asymptote. Okay? And then whenever there's a max, you would do a u. Where there's a min, you do the upside down u. Period again is 2 pi for the cosecant. And you can pick up your calculator and graph it. We'll be working on the rest of the problems, the homework problems in class tomorrow. I will have them online in Schoology, so you can look online to find them.